All right, everybody, welcome back to Number Sense Academy. And today we're going to look at a very, very important topic. That's right, the topic is numbers. Now, this is a very fundamental topic to mathematics. If we're going to improve our mathematics skills and our understanding, then we have to know what numbers are, what they mean, the different types of numbers, and how they show up in our mathematic encounters. So we are going to um, between differentiate the different types of numbers, right? So let's look at the very first type of numbers that we're probably most familiar with, and those are called the counting numbers. These are called the counting numbers, and these are numbers that we use in everyday life. Okay, so when we think of 1, 2, 3, 99, 100, 1,000, and so forth, these are all the counting numbers. We also refer to them as the natural numbers. Okay, and when I first learned about these, my math teacher told me that they were called whole numbers. Okay, so we have counting numbers. The next set of numbers that we have, which are very important, they're all important, but we have integers. Okay, and integers include the positive and negative numbers. So it includes both positive and negative numbers. All right, so if you think in negative 10, negative 8, negative 1, um, we also throw 0 in there, and we have the positive numbers 1, 2, 3, and so on. Okay, so we know that these numbers continue to infinity in either direction. But once we include the positive and negative numbers, and if you want to think of it as the positive, as long as they're positive and negative and they're whole numbers, then those are integers. Okay, positive and negative natural numbers are integers. And then we have the the numbers that represent quantity. So we call these numbers that represent quantity or parts of quantity. More specifically, parts of quantity. So there's really two groups, and the first group is the rational numbers. And the rational numbers mean that you can divide two integers. So you take one integer and you divide it by another integer. And they have to be integers. Okay? So they can be negative or positive, but they have to be integers. So, for example, 4 is an integer. Okay, 4 can also be written as 4 over 1. Let's see. So, sorry, 4 is a rational number because it can be written as 4 over 1. And we see that there are two integers. So we have the 4 that's an integer and the 1 that's an integer. And then we have 5 over 8. So this is a rational number because 5 is an integer and 8 is an integer. Then we have 1.5. This is rational, not because it's in the form that it's in, but because it's also equal to 3 over 2, which is a division of two integers. Okay? And then another example would be 0.66666 repeating. So this 6 goes on forever. So normally we put a little hat on top, right, to show that that value is repeating. In this case, all the 6's are repeating. So I wouldn't have to write all these 6's. I just write the first 6 and then put the little hat on top to say, yeah, this number goes on forever. But because the 6 is repeating, I can also write this as 2 over 3, which is the division of two integers. So that makes these numbers rational. Now let's look at another type of numbers that represent quantity, and these are irrational. These are irrational numbers. So they cannot be expressed using two integers. Okay? It cannot be written as a division of two integers. So let's just put that down. Cannot be written as a division of two integers. For example, root 2. The square root of 2. Or pi. So typically we write pi as 3.14 and some repeating numbers. And believe it or not, as long as I've been teaching mathematics, I do not know what the value of pi is. I cannot repeat it beyond more than 3.14. But I could find it, and it's 3.141592653, and so forth. The square root of 2 is the square root of 2 is 1.1 or 1.414214. So these numbers, we don't know what two integers divide, that when you divide them, you end up with 1.14214 and so on. And saying that we don't know what two numbers that when we divide pi, we end up with these numbers. Now, because this number goes on, sometimes they approximate pi to be equal to 22 over 7, but that's not true. We don't know that for a fact. All right. So these are irrational numbers, and you can normally tell irrational numbers because they don't terminate, they don't repeat, they just go on forever. And we don't know what two numbers will get us those values. So repeating decimals, terminating decimals, those tend to be rational because we can find the two integers that when we divide them, we get those values. Okay? All right, so far we've covered counting numbers, integers, and rational irrational numbers. The next set of numbers that we look at is called real numbers. And this is a bigger category of numbers. So real numbers include integers, right? They include if they include the integers, then that means they include the positive counting numbers. So those are included as well. So we can just put that down. We're going to include both rational and irrational numbers in this group. And of course, because we have the integers, that means 0 is there as well. So all these sets of numbers together make up what we call the real number system. All right. All right. Another set of numbers is what we refer to as imaginary numbers. These are called imaginary numbers. And how do we get to this? Well, if you ever try to take the square root, and we'll get into this stuff in another video, the square root of a negative value, we'll say a, this is not possible using real numbers. All right? So if I try to take the square root of a number, what I'm saying is that this negative number, this negative a, I'm saying that there are two numbers out there that when we multiply them together, right, we could call them, say, b1 times b2. When we multiply these two numbers together, no, sorry, it's not b1 times b2, it'll be b1 times b1 because they have to be the same number, right? b1 times b1 is equal to negative a. Now we know that from our rules of operations that when I take a negative number and I multiply it by a negative number, I end up with a positive number. And when I multiply a positive number with a negative number, I end up with a negative number. And when I multiply two positive numbers, I end up with a positive number. So this is not possible. These numbers would have to be the same sign for them to be equal, and then when I multiply them, I end up with a negative value. That is impossible. So the only way that we solve this is by creating these imaginary numbers, and we won't get into that today. This is for another video. Now, you can take the root of a negative number. So if I want the third root of negative 27, it's saying when I multiply three numbers that are factors of each other, I end up with negative 27. Those three numbers are negative 3 times negative 3 times negative 3. These two gives me 9, then times negative 3, I end up with negative 27. All right. So you could probably pick up from there that if you have a even numbered root, or if you want to find an even numbered root of a negative number, that is automatically imaginary. So that won't work. That'll never work. Now I mentioned rational numbers, and I'm just going to go a little bit further and just talk about fractions. Okay, fractions is a bigger group of, you could roll up irrational numbers and rational numbers to fractions. Okay, and fractions, they represent parts of quantity. They represent parts of quantity, and it's just two numbers, just like we said before. We're dividing one number divided by another, which means that fractions can be rational, they can be irrational, and since it's one number divided by another, they can be real or imaginary. All right? Okay, so now that we have that out of the way, we have the counting numbers, integers, we have the rational numbers, real numbers, imaginary numbers, fractions. Let's just go through a few examples to make sure that we got this down pat. So if I look at the number 9, so let's look at some examples. So if I look at the number 9, what can I take from this? So the number 9, it is a counting number. So it's a counting number. You can write the hash sign for a number. It is an integer. It's an integer, a positive integer to be exact. It is rational, okay, because we could write it as 9/1. And it's real. It's a real number, okay? If I look at -3, this is not a counting number, but it is an integer. It is an integer. It's negative. It's rational. Again, -3/1. Two integers divided by each other. And it's also a real number. If I look at 3 pi, all right, it's not an integer, okay? It is irrational because I'm taking pi and I'm multiplying it by 3. I'm still going to get a rational number. It's irrational, but it's a real number because irrational numbers and rational numbers make up part of the real number system. If I go to the root or the square root of -10, then this is solely an imaginary number, right? Because I can't take the square root of a negative number. Another one, if I have -3/7, what's happening here? So it's a fraction, so we'll make note of that. It is rational. There's an integer divided by another integer, and it's real. All right. And what if I take -√7, negative square root of √7? Now, it is irrational, right? If you plug 7 in on a calculator and you take the square root, you're going to get a negative, you're going to get a value. But we want the negative of that. So it's still irrational. It's not an integer. It's just an irrational number. But it is a real number because I can take the root of 7 and then make it negative. Okay, what if I have negative root of -3/2? Now what I have a fraction, right? I'm dividing two numbers. But because the top, the numerator, is imaginary, then the whole thing becomes imaginary. It's going to take on the characteristic of this part. This can't make it not imaginary. However, if I have -√3/2, this is a fraction, right? Two numbers divided by each other. It is irrational because √3 is irrational, and it's real. Okay, so that concludes our lesson on numbers. So don't forget, there's the counting numbers, there's the integers, there's irrational numbers, there's rational numbers. All those together make up the real number system. And then we have imaginary numbers when we try to take the square root of a negative number. Thank you.